graphing. We're going to just kind of get introduced to them today, and then we'll extend on this in the next couple of units, okay? So kind of refreshing our memory in a couple terminologies. The quadratic here, okay, is a function that can be written in that ax squared plus bx plus c, which is what we call what? Standard form. Okay? Where a, b, and c are the real numbers in front of the variables. An example would be I could have y equals 5x squared. That's a quadratic. I could have and that has no b or c term. I could have it where it doesn't have a middle b term, so it just says 2x squared plus 7. And I can have it with all three terms. You'll never ever have a quadratic without the x squared, because it's not a quadratic then. If the x squared is gone, it's now a line. So if you don't have an a
What if it only has the x squared?
right there, then it's still a quadratic. Okay? It has to have the x squared for it to be a quadratic. Okay? So again, this is just more terminology that just kind of reiterate. A is the coefficient of the x squared term. Okay? B is the coefficient of what? The x term. And then c is what we call the constant term. There is no variable associated with it, it's just a number. Alright, the graph of a quadratic function is what we know as a parabola. Okay, and it's going to look something like upward U, or it could look something like a lower U, or downward facing U. It could be one or the other. Like an N, yeah. Or as I'm going to refer to it as smiley face or a frowny face, and you'll see why. Okay. So you actually can look at a quadratic function and be able to plot the graph just by knowing a few things. And so what we're going to do is we're going to spend some time here and just kind of telling you what you would need to look for in a quadratic to actually be able to take a quadratic and plot it without really knowing much more about it. Okay? The y-intercept of a quadratic, if you notice, you have the x-axis here and the y-axis here, or if you want to put the x here, this is your x, and that's your y. Okay? The quadratic will always cross over the y-axis somewhere. It's always going to cross over here once. Okay? And you can find that value just by having x0, and then c would be your y-intercept. Okay? So whatever quadratic function I have, if I make x0, I'm left with just my constant, aren't I? So when x is 0, meaning x is 0, your constant value is going to be where it crosses that y-intercept. So I could find my y-intercept without just by looking at my quadratic function and knowing that. Okay? My axis of symmetry, which is, so a quadratic, the parabola is the same on both sides, right? There's a part where the very bottom or top part here is where like it stops and it flips. So right here, if I drew a line, the left side is the exact same as the right side on a parabola, right? This little line that divides it in half, where you could actually take it and fold it and be the same, is called the axis of symmetry. Okay? So symmetrical, so it's the same on one, it's the same on the other. And you can find that axis, that up and down, as x equals the negative b value over 2a. So when you have it in standard form, you just take your b value, make it negative b, and that's over 2 times your a value. And that will tell you where the parabola is going to split up and down. Okay? So in looking at that, if you notice that, like on this graph here, I have a most down part, and this one here I have a most up part. Okay? That is what we call the vertex. The vertex is that point of change. So point of change. Okay? And so you can find the x-coordinate of the vertex by then just negative b over 2a. So whatever value you get there, that's the point. And then the y value will be when you plug that x value into it. So let's say this was 2. I take 2 and I plug it into my function, and I'll get a y value. that is my coordinate of the vertex. Okay, so that's my x, and then my y is going to be, so the coordinates will be this one right here, so negative b over 2a, and then my y is going to be value when negative b over 2a is plugged in. Kind of a lot of words. So again, whatever this value is here, I take it and plug it into my function. I'll get a y value, and then those are my coordinates for my vertex. That will tell me my most bottom or top point. Okay, that point of change. So somewhere in here, if you don't have it, vertex is point of change. I know I wrote it right there, but just so you reiterate. Okay? Okay. So then, if you recall, domain is all my x values that I could use to make that a true statement. And with a parabola, your domain is always going to be all real numbers. Because a parabola, if you notice here, it can go anywhere to it's just infinity going up this way, infinity going up this way. So all your x values can be used because they're going to just keep going on and on and on. Same thing with here. So your domain will be all real numbers. You can use all x values. Okay, so all x values. Your range, on the other hand, is going to be determined by your vertex. Okay, so your range, if you notice here, is going to be your up and down. Well, my line, like where my vertex is, it will never go below this part, right? And here, it'll never go above. So my range is always going to be my vertex up or my vertex down, depending which way the graph is facing. Okay, so your range is going to depend on vertex. Okay, and it's either going to be y is greater than or equal to your vertex, or y is less than or equal to your vertex. If it's going up, or if it's going down. Does that make sense? Okay, and then the x-intercepts are what you guys just did. You solve for x. And the quadratic function tends to be the quadratic formula tends to be the most popular on these because you tend to get more complicated formulas or equations. If you have one that's easily factorable, do the factoring, etc. But this is where we go back to solving for x. These goes back into those the four that you just did. Okay, so you can do factoring, quadratic formula, completing the square, etc. Okay, and so you get x equals. Your whole point is get x equals, and that's just showing you where it's crossing the x-axis. Okay. All right. So just by knowing this, we can take and actually graph a function. All right. So let's.
Can you have points that don't cross the x-axis?
You definitely can, and you'll have it where it looks like this,
Yeah.
and then you'll get the two imaginary numbers when you actually solve it. So that kind of goes back to that when we talked about the four different numbers you might get in the discriminant. When you get that negative discriminant, you'll have it where it does not cross the x-axis, and you'll have two imaginary numbers. Okay? Good question. All right, so let's just take an example. Here we have a function. Okay, x squared plus 8x plus 9. Okay? First of all, is it...
Yes.
All right, so therefore, what is a? What's the value of a? 1. What's the value of b? And the value of c. All right, excellent. Okay? All right, so now we want to find the axis of symmetry. So we're going to do that x equals negative b over 2a. All right? So b is 8, so it's going to be negative 8 all over 2 times 1. And that just becomes negative 4. Okay? And what that means is where x is negative 4, so I'll go over here, 1, 2, 3, 4, I have an axis of symmetry. So my parabola is going to break on this line. Okay? So I know it's going to go up around this one or down around this one. That's the line it's going to break on. Okay? So now, my vertex, well, I definitely know my vertex is -4, because up here, our vertex is that value, and then we plug it in for y. So I know it's -4. So to find my y, I just take this value and I plug it into the function I have here. So I'm going to do -4 squared plus 8 times -4 plus 9. Okay, so everyone see how I just took the -4 and plugged it in there? Okay, and I just solve for it. So I'm going to get 16 minus 32 plus 9, and that is going to equal -7. Okay, so it's 16 minus 32 plus 9. Okay, and so that equals -7. So then my vertex becomes this number and that number. And that means that's the point of change. That is where it's going to change. So I could go to -4 and then -7 and put the dot right there. Okay, and that's going to be my vertex. Okay, so now I have to ask myself, okay, will the parabola open up or down? So this is opening up. Okay, that's opening up, and this is opening down. Okay, and there is one key factor you can look at to determine if it opens up or down. So do you guys remember the absolute value?
So it's going to be the negative or a positive of x squared?
It is. It is. It's the a value. Just like with the absolute value, we always look to the a value. If a is positive, it's going to open up. If a is negative, it's going to open down. Okay, so we look at the value of a. If there's no number in front of it, so it appears, what's the coefficient always? 1. Okay, so a is 1, because a is 1. Is it a positive or negative? Positive, therefore it's going to open up. And the way I like to look at it is when you are positive, like a is positive, you're smiling and your smile opens up, right? Get it? When a is negative, you're not positive and you then frown. That's the way I remember it. I don't know, works for me. It did work for me in high school. I still use it. Okay, so that's how I look at it. When you're negative, you're usually frowning. When you're happy or up or positive, you're usually smiling. So anyway, so it opens up. When it opens up, you guys, that means my graph is going to go this way. Okay, so is this the most minimum or most maximum point I'm going to have? Minimum. So when it opens up, the vertex is going to be a minimum. Okay? Right, when it opens down, it's going to be maximum. Okay? So now it wants to know the y-intercept, and the y-intercept is going to be that 0, c. So it will be 0, 9. You guys got it. So that means I could take this point now, 0, 9. I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And I know that my chart is going to go something like this. It's going to curve something like up to there, and then keep going. So I actually have 2 points, and I can kind of see what my graph might look like. And remember that whatever it is on one side is going to be the same on the other. So if I went over 4 and up to the 9, I could go over 4 here and all the way up to the 9 here, couldn't I? Right? Because it's going to be the same on both sides, because that's what a parabola is. So you can kind of graph your, just by those points, can graph what your parabola would generally look like. Okay? Alright, it wants to know y-intercepts, and the y-intercepts then we would probably want to use the quadratic formula in this. You can factor it. On this one, you don't get pretty numbers at all. So we would do the quadratic formula, and I'm just going to put it into it. I'm not going to solve it for you. I'll just tell you what the answers are at the end. But it would be, again, negative b plus or minus the square root b squared minus 4ac all over 2a. Okay? And so therefore that would just be negative 8 plus or minus negative 8 squared minus 4 times 1 times 9, and that's all over 2. And when I do that, I'm going to get negative 1.35 and negative 6.645. Okay? I'm not going to have you guys go through that. Trust me on that. Yeah, I wish you could round it right. So what that means is at negative 1.35, when x is negative 1.35, which is approximately right there, that would be a point. And then at negative 6.64, about right there, that would be a point. Okay, so then you take those, since they are x equals this, right, x equals, at those points, that's where it's crossing the x-axis, right? So then I could kind of connect the dots here, okay? And that would be, in general, kind of my graph, okay? This one actually should go right through there, that point right there. Okay? So that, just by doing those points, you can kind of make a graph. And it should, again, it should be the same on the left as on the right. That's your axis of symmetry. It is divided in half. Okay? And then, so what is the domain? All real numbers. You got it, all real numbers. And the range, then, is looking at the vertex. Remember, the domain is your x values. And then your range is going to be your y values. Okay. So what would my range be? What values of y can I have? Well, it comes from here and it all goes all the way up, right? So my range is going to be from this line up. Okay. So y is going to be greater than or equal to negative 7. Yep. Okay. Good so far? So we started with the vertex, okay, so we found the axis of symmetry, and then that value becomes the x value. I take that and I plug it into the equation until I get the y value at that point. So that's my vertex. That's going to be the bottom point here, okay. Then, because A is positive, I know it's going to open up, okay. Then I find my y-intercept, which is the 0, c, and I plot that there, okay. Then I just found my x-intercepts and plotted those two, and then I kind of just started drawing it. Okay. Now, another thing you can do is the t-table. Okay. And the only one thing I want to point out about the t-table, we're used to just kind of plotting in any numbers like 0, 1, and 2. We try and find smaller numbers in a t-table. Okay. But on this one, you really want to follow this. Your vertex coordinate should be to the middle numbers here. Okay. So when I'm doing the t-table, I should plot my vertex coordinates as the middle numbers here, and then I should go like 1 up and 1 below. So I do like -3 and -5. Okay? So when you're asked to do a t-table, you want your vertex coordinates to be the middle point, which is obviously already determined for you, and then pick 1 up and 1 below and solve, and you should find that they're both the same. Okay, because if the vertex are going to be the same on each side, right? It's mirror. So if I put in a -3 here, I'm going to get -6 as my value. Okay, that's going to be like -3 squared plus 8 times -3 plus 9. Okay, and that's going to give me -6. When I put in -5 squared plus 8 times the -5 plus 9, I'm going to get a -6. Okay, so when I do that, I'm going to get, okay, -3 is going to be -6, and then -5 is going to be -6. So those would be those points right there, and then you can see how you graph it. Okay? So on the t-table, when asked to do it, you want your vertex coordinates to be your starting point. Okay? And then go 1 up, 1 below. Or you go 2 up, 2 below, whatever. Just do the same distance above and below. And then you should see that they're the same, and that kind of gives you your curve. Okay?
All you have to do is plug the x in.
Yep, plug the x in and to find your y. Okay? Alright, let's flip. Okay, so we just talked about this, so this hopefully is review. If A is positive, meaning greater than 0, it will never be 0. A will never be 0, because if it's 0, it's not a quadratic, right? If it's greater than 0, it opens up. Okay, and it's going to be the minimum of the function. If it's negative, it's going to open down, and it'll be the maximum. Okay, so opening up looks like this, and it's a minimum. Opening down looks like that, and it's a maximum. Okay? So looking at these two functions here, I have x squared minus 4x plus 2. Is that going to open up or down?
Up.
It's going to open up because a is a positive 1. So therefore it is a minimum or maximum? Min. On this one here, it's negative x squared. So does it open up or down? Down. And it's a max. Okay, and it opens up because a equals 1, which is positive. And this one is a equals negative 1, which is negative. Okay? Alright, so here we have this example here. I want you guys to try this one on your own, referring to what we just did. Okay, so go ahead and try this one and see how you do. Okay, so first of all, is it in standard form? Yes. So then A is what? Negative 1. B is what? 2. And C is what? 3. Okay? So now we need to find the axis of symmetry. And the axis of symmetry is this equation that says negative B over 2A, right? So this is where you need to be careful because you have negatives with negatives, right? So I have negative B, which is going to be 2. And that's divided by 2 times A, which is negative 1. Okay? So this becomes negative 2 over negative 2, which is just then 1. Okay? Does everyone see how I did that? Okay? That's why you have to be very careful that you use your negatives correctly. So now I want to find the vertex. So I just take this 1 and I plug it in to find my y value. My vertex is going to be 1 comma something. I don't know what that is yet. I take and plug it in. So I have to plug this in. So I'm going to do, my equation is negative x squared, so put in the 1 squared, okay, plus 2 times x, which is 1, and then plus 3. So this becomes 1 squared, which is 1, times a negative, which becomes a negative 1, plus 2 plus 3, and that's 4. Okay? Yes? It's outside of that x squared, right? So that's where you guys need to be careful on those negatives, okay? So then your vertex is 1 comma 4. Okay, so I can go to 1 and go up 4, and I can put that point there. That's my vertex, right? So vertex. Alright, so now I want to know, does it open up or down? So what do I look at to see if it opens up or down? A. Is A positive or negative? So therefore it's going to open down. So I know it's going to look something like this. Okay? So it's going to open down. So therefore will be a maximum or a minimum?
No, maximum.
Maximum. Okay? Alright, so now I need to find the y-intercept. Okay? So find the y-intercept. 0, comma 3, right? So it's just 0, comma C. So it becomes 0, comma 3. So I can go to 0 and up 3 and put that point there, and I know then it's going to cross right there. Because I went over 1 and up 3, I could go on the other side over 1 and up 3 and put a point there, couldn't I? Because it's a mirror image, and this is the axis of symmetry. That's where it divides it in half. So whatever I do to one side, I can do to the other, and it's going to be the same. Okay? So I know that my graph looks something like that so far. Okay? Does that make sense? Okay? Now you want to find the x-intercepts. Okay? So you want to find the x-intercepts and decide where it's going to cross this axis, because you can tell it's going to go down. It's going to hit it somewhere. Okay? You could do the quadratic formula. You could do factoring if you wanted to. You decide. So you guys go ahead and try to find the x-intercepts. Alright, so the x-intercepts are going to be, you could do it a couple different ways. I'll do the quadratic. So negative b, so negative 2 plus or minus the square root of b squared, which is 4, minus 4 times negative 1 times c.
Where did you get 4?
2 times 2.
Yeah.
b squared.
B squared.
Would you like me to write it as 2 squared? There, b squared. Does that make it feel better? Okay, all over 2 times a, which is negative 1. So I'm going to get negative 2 plus or minus, okay, this is 4 plus 12 all over negative 2. So I'm going to get negative 2 plus or minus the square root of 16 over negative 2. That's negative 2 plus or minus 4 all over negative 2. So then when I do that, I'm going to get negative 2 plus 4, which is going to be 2 divided by negative 2, and that equals negative 1. Then I have negative 2 minus 4, which is negative 6 divided by negative 2, which is then 3. So I have two intercepts. I have negative 1 comma 0, and I have 3 comma 0. Okay? So it's going to be 0, negative 1 here, and then 0, 3. And so I could go down like that and connect the two dots. Alright, questions on that? Yes? The 3 I did, so this is going to be negative 2 minus 4 all over negative 2. So it's negative 6 over negative 2, and that equals 3. Okay? So what is my domain on this one? What is my domain?
All real numbers.
All real numbers. And then what is my range?
Let's see, 4.
Range is going to be y is less than or equal to 4. Well, you go to where your vertex is, right? And the y values can only be from this point below, because there's no, the graph does not go up here at all. So this is my y value, and it's this or anything less than y. Yeah, so it's less than or equal to 4. So I can use any value of y that's 4 or less. That would...
That's not 4, is it?
Yeah, this is
Up
my vertex 1 and 4.
4. I got 1 and 6.
For your vertex? This should be a negative 1, not a positive 1.
Would you graph symmetry?
So you can kind of see how we can take these points and create your graph. Any other questions on the range and domain? Alright, so if I would have you guys do a T-chart, what would be the values that I start with? 1 and 4. So 1 and 4 go here, and then maybe go 1 up, 1 below. So I might go 0 and 2. If I plug in 0, I'm going to get 3. And if I plug in 2, I better get 3. So it's going to be negative 4 plus 4, which is 0 and 3. So this will be 3. So then you can see that you get the same point above and below. Yes?
So is that always it is?
Yes. You always start, your starting point on a T-chart will always be your vertex. And then go like 1 above, 1 below.
So, I mean, if I calculate the first point right, and the 3 always, the other point is a 3?
The other point should be a 3. If you calculate the vertex correct, if you go up 1 and down 1, the value should be exactly the same because it's a mirror image. So if I go over 1, it should be the same as if I go the other way 1. Yeah.
So, okay.
Why?
I'm going to start on example 5 first because you don't have to create the equation. I think I'd rather just give you an example of how you use an equation with this versus creating the equation. Okay? So here's an example. We have a small independent motion picture company determines the profits for producing a DVDs, okay, of a recent release. And this is an equation that they came up with, okay, so you're not creating the equation, you're told. And they want to know, the profits in thousands, by the way, they want to know how many DVDs should the company produce to maximize the profits, okay. So this is what companies do all the time. What is the maximum amount that they should produce, and at what price should they actually sell them at, okay. So when you see crazy, you know, ticket prices for $5,000 or $50,000 or something along those lines, and you're freaking out, like, how could they even make money? They'd sell more if they sold it for less. But the thing is, yeah, they'd actually maybe sell more, but the profits wouldn't be as much. There's actually a point where you actually make more money based on the price that you have. So sometimes lowering the price does not give you bigger profits, and sometimes increasing the price does not give you profits. So this is a completely realistic situation when you see the prices, how they start out. They want to try and maximize those profits, okay? So they want to know, so what you're solving for in all these story problems, you guys, this is key, you need to hear this. What you're solving for is the vertex. That is what you're solving for, because that is the point of change, where it's the most max or the most min. So when you get a story problem like this, and it's saying maximize or minimize, it's asking for the vertex. And the vertex is going to give you an X and a Y, and that X tells you how many and like a price. Right? So your X value is telling you how many, and then this is the price you should sell it at. So the story problem is that's all that you're looking for is a vertex. Okay? So if I tell you that that's the case, how do I find my vertex? Okay, so we're looking for vertex. All right? The fact that it's maximizing tells me it's a kind of a parabola that looks something like this, right? And the maximum is going to be right here. What do I know about the A value on a parabola that looks like this? It's negative, right? Well, look. Notice how it's negative there? Okay? All right, so I'm looking for the vertex. What's the formula for a vertex again? X equals what? Negative B over 2A. Okay? So let's just mark, what is my A? My A is negative 0.02. My B is 3.4. Okay? And then my C is negative 16. So make sure it's in standard form. Find your A, B, and C. Right? All right, so now I'm just trying to find my vertex. So let's find what X is. X is going to be negative B, which is 3.4. And that's going to be all over 2 times A, which is negative 0.02. Okay? So you plop that into a calculator. Okay? And when you plop into a calculator, what do you get? Okay, so this is going to be 0.04 on the bottom. And then I have negative, that's a negative. I have a negative 3.40. So I'm just going to take 3.40. I'm going to divide by 0.04, and I'm going to get 85. Okay? Okay, so I did take 0.02 and times it by 2. What do you get? You get 0.04. It's going to be negative, right? Take a negative 3.4 and divide by negative 0.04. You should get 85. Plug it into your calculator. All right. So, okay, so now, what did I just solve there? You guys, 85 then represents how many DVDs?
85.
Okay, so I need to sell 85 DVDs. Well, how much profit will I make if I sell 85 DVDs? So what do I do with that value? I plug it back into my equation, right? Because I'm looking for the vertex. So I take my 85 and I'm going to plug it into that negative 0.02, 85 squared, plus 3.485 minus 16. Okay? So when I do this math, I get negative 0.02 times 7225, and that's going to be plus 289 minus 16. This becomes a negative 144.5 plus 289 minus 16. So my profit is going to be 128.5 thousand. So when I sell the 85 DVDs, I make $128,000. If I sell more or sell less, my profits change. Okay? But that's the maximum, so this is the maximum amount of money I'm going to make. Okay? And how that works, it's like you're like, well, why can't I sell more DVDs? What happens then is the cost to actually make those DVDs start cutting through your profits, so then the profits start going down. So that's what companies do. Okay? So all you're trying to do is you're looking for the vertex. You find this value here and you plug it into your equation. All right? So let's have you guys try this one. Okay, you're going to try this one. All right? You need to know how many trees will minimize the cost per tree. Okay? And what is the cost per tree? So you're looking for the X value here, and then you're looking for the Y value there. Okay? Does that make sense? So find your A, B, and C, and then try to find your vertex. And then when you find your vertex, the X value will tell you the minimized cost, and then the Y value will tell you how many trees. Okay? Give it a shot.
Yeah.
All right, so you're trying to find the vertex. You have A is 0.001, you have B, which is negative 0.3, and you have C, which is 50. So x equals negative B, so it's negative and negative 0.3, all over 2 times A, which is 0.001. So this becomes 0.3 divided by 0.002, which is 150. So you need 150 trees.
Yes.
Okay? So you take 150 trees, and you figure out their cost, and that's going to be 0.001 times 150 squared minus 3 times 150 plus 50. So this...
It's minus 0.3.
Oh, 0.3, right.
Yeah.
Thank you. Then I have, this becomes 2250, and that's minus 45 plus 50, so it's 2250 plus 5, which is 27.5. So to minimize the cost per tree, you want to sell 150 trees at $27.50. Okay? All right. We're going to move up to the top one.
It's not half a tree, it's just a Charlie Brown tree.
Okay. So, to give you the quadratic, you have to determine the quadratic. These are the problems no one likes. Okay? But I actually used this the other day. We had gotten some, I wanted to build a garden, I should say in the summer. I built a garden, and my neighbor actually had a bunch of like chicken wire fence. So I only had so much chicken wire fence I could use without having to go to the store and buy some more. So I actually did this type of problem. Just saying. I wasn't doing it for the purposes of this, but I did it for like a garden. I want to have like tomatoes on one side and like other vegetables on the other side. So anyway, this is a dairy farm. It has a barn. Okay, there's my barn. Okay. And it has 250 feet of fencing, so it can only have 240 feet. You're not going to go past that, okay? And it wants to use it all in 2 identical pens, so it basically wants to have something that looks like this, okay? And so your fencing is going to be this, here, and here, because you're along the side of a fence, okay? And it wants to maximize the area, okay? So we're going to do a maximize. So we're going to try and find a vertex. That's what we're going for, okay? So we have to create the equation. So here, if I have a side here, what do I know about these other 2 sides? They're all going to be the same. So if that's an x value, these are all going to be the same, correct?
Yeah.
So whatever I use here, what am I left with for this side? I'm left with the 240 minus those 3 sides, right? Not x cubed, but 3x. Almost. Okay? So this side here, you guys, is going to be the 240, which is my total, minus what each side is, right, that I've already used. So everyone see how I did that?
Yeah.
Okay. So it wants to maximize the area. So my area is, what's my formula for that? Length times width, correct? Okay? So that is my area, right? So I know that my length on this one is 240 minus 3x. That's my length, right? This is my width. So my width here would just be x. So I can take, when I know this, I can then plug it into this formula. And then look what I'm going to get, you guys. When I do the distribute property, I'm going to get a negative 3x squared plus 240x. Right? Now, I need to maximize the area. What type of parabola do I have? Do I have an open up or open down? I have an open down. So if I'm trying to maximize, oh, look at that. The vertex will be on the top because it opens down because my A is negative. So you guys that's like a key, like, hey, I'm in the right frame of where I'm supposed to go, right? All right, so what do I need to do to maximize my area? What am I trying to find? Try to maximize or minimize. What point am I trying to find? The vertex. I'm just going straight to the vertex. So, what is my A value here? Negative 3. What is my B value? 240. And if you were asked, what is C? 0. Okay, so X. Let's find the X value of my vertex. It's negative B over 2A. So that's going to be negative 240 all over 2 times the negative 3. So that becomes 240 divided by 6. I got 3 from the A. A is -3. Does that make sense? So I'm just trying to find the vertex, and the x value of my vertex is at negative b over 2a. So I just plug in my a and b values. Okay? You good with that? Okay, so then I get that 240 divided by 6 is what? Is positive, because I have negative 240 divided by negative 6, that becomes a positive 40. Because it's -3, right? So therefore, x is 40. So therefore, this is my x value right here, isn't it? I know now that's 40. This is going to be 40, this is going to be 40, and this is going to be 40. Right? Can I figure out my length now too? Yeah, my length would be 240 minus 3 times 40, which is 120. So if I make a pen, or whatever you want to call it, I would do 40 by 40 by 40 and then do it by 120. And that would be that would maximize my area. If I want to find out what the maximum is, then you take that and you plug it in, and then you could find out what the actual area is. So if I take this and plug it in, okay, I'm going to get -3 times 40 squared plus 240x, or times 40. And then this is going to become, I don't have the math in front of me, 40 times 40. And then times it by -3. This becomes -480. Or 4,800, and this is plus 9,600. And my maximum area then equals 4,800. Okay, so I took what I knew, created an equation, took the a and b values, found my vertex. Once I knew what x was, I could find out what all the lengths of the sides were, and then I could also determine the maximum area by finding y. So aren't you glad I did that one last? Quick. So, going back to page 1. We talked about the quadratic, what the a, b, and c values were. We used the y-intercept, the axis of symmetry, which is where the parabola changes. We found the vertex point, taking that x-coordinate and plugging it in and finding y. The domain is all real numbers for x, and the y is going to determine on where your vertex is. Okay? So wherever my vertex is, y up or y down. Solving for the x-intercept, you guys should know that from our past units. Okay, just quadratic. I think that's it on that one. The T-chart, you guys start with the vertex and then go up one, up one, down one. I think that's it.